You don't need a motivation, you need a system. Train like this. Wake up early and plan for the day before your feet hits the floor. Study while others party. No one notices your sacrifices or hard work. No one will thank you or applause for your commitments. When the results come, don't argue, don't explain, and don't try to prove. Win quietly and let your results speak. Because when you win, you just don't get attention, you get the power. And today's topic is on test of significance of small samples. And in my previous video, I have completed the student t-test for single mean. And in today's video, I am going to teach you the student t-test for difference of means. See, example 1 and 2 are already in my previous video. And this is from example 3. Below are given the gains in weights in LBS. So what is this LBS? So in the context of weight, LBS is an abbreviation of pounds, a unit of weight in US customary system. It's a Latin word libra, so which means a scale or balance of pigs fed on two diets A and B. So this is diet A and this is diet B. So these are all the diets related to the diet of diet A and this is diet B. So this is the data given. So here when you observe, no mean is given and no standard deviation is given. So it is that we have to calculate and test if the two diets differ significantly as regards their effect on the increase in weights. So first thing is, first we have to find out the mean value. So for finding the mean value, so how many values are there here? 1, 2, 3, this is 4, 5, 6, 7, 8, 9, 10, 11, this is 12, this one is 13, 14, and this one is 15. Clear? And diet A, so the sample 1 is 12, and next one for diet B, the sample B is 15. So if you observe this one, the first one is N1 is equal to 12 here. So this one is 12, up to 12 we have the values, and for diet B we have values till 15. So N2 is equal to 15. So sigma x. So sigma x, we have to add up all these values, and after addition the value is 336. 336. And next one, the diet B, after adding all these, so this value is nothing but 450. And now we have to find the means. So mean is nothing but 336 by 12. So which is equal to 28. So we got x bar value is equal to 28. And what is y bar? This is 450 by 15. The values of 15. The value here is 30. Clear? And next we have to find out the standard deviation. So these are all the x values, that is diet A, that is 25 till 25. And next one, diet B, 44 till 22. So from 44 till 22, this is diet B, and for 25 to 25, this is from the question. And this is x bar. And what is x minus x bar? X bar is nothing but 28. So we have to subtract each and every value from 28. 25 minus 28 is minus 3. 32 minus 28 is 4. 30 minus 28 is 2. 34 minus 28 is 6. And so on. We have to build the second column. And we have to make the squares out of this. Minus 3 whole square is 9, 4 square is 16, 2 square is 4, 6 square 36, minus 4 square, and minus 14 square is this one. So we have to fill the third column. And the next one in the y, after adding, this is 450, and we got the mean value y bar is equal to 30. That is 450 by 15. So we have to subtract 30 from each and every value of y. That is 44 minus 30 is 14. 34 minus 30 is 4. 22 minus 30 is minus 8. Like that you have to fill this column, and we have to make the squares out of this. 14 square is this one, 4 square is this one, minus 8 square, minus 20 square, 17 square is this one. So we have to fill this column and we have to make an addition. So this is y minus y bar whole square, and this is x minus x bar whole square, and this is sigma x, and this is a sigma y. So after getting, we have to find the standard deviation. For finding the standard deviation, we have a formula ready as S square, variance is equal to sigma x minus x bar whole square plus y minus y bar whole square divided by n1 plus n2 minus 2. So what is sigma x minus x bar whole square? Just now we added from the table, that is 380, and y minus y bar whole square is 1410 divided by what is n1, 12 plus 15 minus 2. So if you put in the formula here, just let me show you sigma. So this is sigma x minus x bar whole square is 380, and sigma y minus y bar whole square is 1410. So if you substitute here, the variance value is 71.6, and therefore standard deviation SD is equal to root over this is 71.6. And now we have to go with the 5 steps. First one is the null hypothesis. So this is null hypothesis. There is no significant difference between the mean increase in the weights due to the diet A and diet B, mu1 equal to mu2. And next one is alternate hypothesis. Mu1 not equal to mu2, level of significance 0.05. And next one is we have to calculate the mean and the standard deviation. Already we have calculated. So after finding out the mean values x bar and y bar and standard deviation, so this is the formula for test statistics. For test statistics, the formula T is equal to x bar. So this is the formula here, x bar minus y bar by root over s square into 1 by n1 plus 1 by n2. What is x bar here? This is 30. Y bar is equal to 28 by root over s square, that is 71.6 into 1 by n1, that is 1 by 12 plus 1 by 15. The value is approximately 0.609. And the next one for degrees of freedom. So we have to check the degrees of freedom, that is n1 plus n2 minus 2. That is 12 plus 15 minus 2, the value is 25. So for 25 degrees of freedom, that is at 5% level of significance. So let me check at T25. So degrees of freedom n is equal to, the value here is 25 at 0.05. That is, see, at student T distribution. So here the degrees of freedom, when you go with 25 at 0.025, the value here is 2.060. The value here is 2.06. So this is the calculated value and this is the tabular value. As the calculated value is 0.6 and the tabular value is 2.06. So here calculated value is less than the tabular value. Therefore, we have to accept the null hypothesis H naught. So we accept the null hypothesis H naught. And then what is the conclusion here? That is, the two diets do not significantly, see here, so do not significantly differ significantly as regards their effect on the increase in the weights. And this is how we have to check when the data is given. So we have to calculate the mean value, means x bar and y bar, and this variance and standard deviation. And next we have to use the test statistic formula as x bar minus y bar by root over s square into 1 by n1 plus 1 by n2. And here is the fourth question. A group of, see here, a group of 5 patients are treated with medicine A, that is 42, 39, 48, 60 and 41 kgs, and the second group of 7 patients from the same hospital treated with the medicine B. So medicine B weighs 38, 42, 56, 64, 68, 69 and 62. If you observe, the data given here is 1, 2, 3, 4, 5. So here clearly N1 is equal to, so N1 for 5 patients and N2 7 patients are given. Do you agree with the claim that the medicine B increases the weight significantly? So first we have to calculate here. So x bar is equal to, so this is the data, that is 42, 39, 48, 60, 41. So we have to place it in the column 1 and x minus x bar. So from where we'll getting x bar? X bar is equal to 230 divided by 5. So x bar is equal to 230 divided by 5. The value here is 46. For y bar, so we have to make an addition, that is 399. So 399 by 7, the value here is 57. So x bar is equal to 46 and y bar is equal to, see here, this is 57. So x minus x bar. So we have to subtract 46 from each and every value, and here we have to subtract each and every value from 57. So this is 42 minus 46. The value here is minus 4. 39 minus 46 is minus 7. 48 minus 46 is 2. 60 minus 46 is 14, and 41 minus 46 is minus 5. So we have to make an addition, that is minus 4 whole square is 16, minus 7 whole square is 49, 2 square is 4, and 14 square is 196, and minus 5 whole square is 25. So if you make an addition, this will be 290. And next one, we have to subtract each and every value from 56. That is 38 minus 56 is minus 19. 42 minus 56 is minus 15. 56 minus 57 is minus 1. 64 minus 57 is 7, 68 minus 57 is 11, and so on. So after making an addition, it is 0, and if you make a square, that is 19 square is 361, 15 square is 225, and so on. This is 926. So now we have to find out the standard deviation. And now see here, so variance formula here is very clear as sigma x minus x bar whole square plus y minus y bar whole square by n1 plus n2 minus 2. So here the total here is 290, and this one sigma y minus y bar whole square total is 926. So if you add up these two divided by n1 plus n2 minus 2, what is n1? 5 plus 7 minus 2. The value here is 121.6. So if you make a square root, the standard deviation value S is equal to 11.03. And next we have to go with the 5 points. First one is the null hypothesis H naught. Here, there is no significant difference between the medicine A and B as regards their effect on the increase in the weights, that is mu1 equal to mu2. Alternate hypothesis, mu1 greater than mu2, and level of significance, that is alpha is equal to 0.05. And test statistics, for test statistics the formula is very clear as T is equal to x bar minus y bar by s times of root over 1 by n1 plus 1 by n2. What is x bar here? So x bar is equal to 46. What is y bar? Minus 57 divided by s. What is the standard deviation here? 11.03. So this is 11.03 root over 1 by n1 plus 1 by n2. What is 1 by n1? 1 by 5 plus 1 by 7. The value after calculating is minus 1.7. So this is the calculated value. If you take modulus, this is 1.7. The tabular value here, T is equal to n1 plus n2 minus 2, which is equal to 10. At 5% level of significance, at 5% level of significance for 10, the value here is given as 1.81. See, for degrees of freedom V at 10 level of significance, the value here is 1.812. So here the tabular value is 1.81. The calculated value is 1.7. So it is very clear that since the calculated value is T is less than the tabular value, we have to accept H naught. So after accepting H naught, the medicine A and B do not differ significantly as regards their effect on increase in weights. So this is how we have to solve. And the next one is two horses A and B were tested according to the time in seconds to run a particular track with the following results. The horse A, this is horse A and this is horse B. 1, 2, 3, 4, 5, 6 and 7. So n1 is equal to 7, 1, 2, 3, 4, 5, 6. n2 is equal to 6. Please remember the sample sizes. n1 is equal to 7 and n2 is equal to 6. We first compute the sample means and the standard deviation. For finding the mean value, so we have to add up all these divided by 7. So after addition and dividing with 7, the value here is 31.286. So this is x bar. And mean y bar is equal to, so we have to add up all these values divided by 6, and here y bar value is equal to 28.16. See here, for finding the variance, so these are all the x values and x minus x bar. So we have to subtract 31.286 from each and every value. 28 minus 31.286 is nothing but minus 3.286. 30 minus 31 point, this one is minus 1.286. 32 minus this one is this one. So we have to fill the second column and we have to make the squares out of this. Using your calci, minus 3.286 whole square is nothing but 10.8, and so on. Fill this column. And next one is y values. You have to place in the fourth column, and the next one y minus y bar. So we have to subtract 28.16 from each and every value. 29 minus 28.16 is this one. 30 minus this one is 1.84, and so on. So after making the squares, we have to fill the last column here, and now we have to make an addition out of all these values. That is, a sigma x minus x bar whole square is nothing but 31.4358, and sigma y minus y bar whole square is nothing but 26.8336. So here the variance is equal to sigma x minus x bar whole square plus sigma y minus y bar whole square by n1 plus n2 minus 2. See here the total, both the totals we have to add up, and this is n1 plus n2 minus 2. What is n1 here? 7 plus 6. So n1 value is equal to 7 and n2 value is equal to 6. That is the 7 plus 6 minus 2, which is equal to 11. And here the value here is 5.23. And this is variance value s square. So for s it is root over 5.23, the value is 2.3. And next we have to go with the 5 steps. First one is the null hypothesis, mu1 equal to mu2. Alternate hypothesis, mu1 not equal to mu2. Level of significance, alpha is equal to 0.05. For test statistics, t is equal to x bar minus y bar by s into root over n1 plus n2. What is x bar here? So x bar is 31.4358. Sorry, x bar is equal to, see here from the table, x bar is one value and y bar is one. See here, x bar value is 31.286 and y bar is equal to 28.16. And now x bar minus y bar. So after subtracting, and this s value is equal to 2.3 times of root over 1 by 7 plus 1 by 6. The value is 2.443. And next one here is the tabular value, that is n1 plus n2 minus 2. 11 degrees of freedom at 5% level. At 5% level of significance, the value here will be, see here, for the student t distribution, degrees of freedom at 11 degrees of freedom at 5% level, this is 2.201. So here the tabular value here is 2.2, calculated value is 2.4. Clearly calculated value is greater than the tabular value, and therefore we reject the null hypothesis H naught. And therefore the conclusion here is, we conclude that the both horses A and B do not have the same running capacity. And the next one is example 6. To examine the hypothesis that the husbands are more intelligent than the wives. An investigation took a sample of 10 couples and administered them a test which measures the IQ. The results are as follows: the husbands, wives. So these are the IQ levels here. Test the hypothesis with the reasonable test at the level of significance 0.05. First we have to calculate the mean as well as the standard deviation. So here the number of couples are 10, n is equal to 10 here. So for n is equal to 10, first we have to calculate the mean value. For calculating the mean, both n1 and n2 are 10 here. So n1 is equal to 10 and n2 is equal to 10. X bar is equal to, we have to add up all the given data divided by 10. The value here is 103. So x bar is equal to 103. Y bar is equal to, we have to add up all the values divided by 10. The value here is 95.8. So this is y bar value. So here this is the table here. These are all the x values and x minus y bar. So we have to subtract 103 from each and every value of x. That is 117 minus 103 is 14. 105 minus 103 is 2. Likewise, we have to fill this column. And next one, we have to make the squares. That is 14 square is 196. 2 square is 4 minus 6 square. And we have to fill this column. And the next one is y data from the question. After filling y, what is y bar here? 95.8. So we have to subtract each and every value from 95.8. That is 106 minus 95.8 is this one. 98 minus 95.8 is this one. So we have to fill this column. We have to make the squares and we have to make an addition for this. So for the variance square, that is sigma x minus x bar whole square plus sigma y minus y bar whole square divided by n1 plus n2 minus 2. The addition here is 1606 plus 1679.6 divided by, what is n1? So n1 is equal to 10 and n2 is also 10. That is 10 plus 10, 20 minus 2, which is equal to 18. The value here is 182.53. So here this value is the variance s square. And for standard deviation, so we have to make a square root. So square root of this one, 182 this is 53. So this is the standard deviation. The value here is 13.51. And next we have to go with the null hypothesis. It is very clear that null hypothesis mu1 equal to mu2, alternate hypothesis mu1 greater than mu2. That is, the husbands are more intelligent than the wives. So next one is level of significance, alpha is equal to 0.05. Test statistics, x bar minus y bar by this one. What is x bar here? So here x bar value is equal to 103. Y bar value is equal to 95.8. 103 minus 95.8 by, what is s here? Standard deviation, that is 13.51 by root over 1 by n1 plus 1 by n2. Here n1 is equal to 10 and n2 is also 10. The value here is 1.19168. At degrees of freedom, that is n1. So this is n1 plus n2 minus 2. That is 10 plus 10 minus 2, which is equal to 18 degrees of. So this is degrees of freedom. So we have to check from the table here at 5% level of significance for degrees of freedom at 18. So the value here will be, see, at 0.05, that is 1.734. See here, this is 1.734 is the tabular value and calculated value is 1.19. So if you observe, this is 1.1 is lesser than 1.7, and therefore we have to accept the null hypothesis and there is no difference in the IQs. And this is how we have to calculate each and every time. We have to calculate the mean value, so we have to calculate the standard deviation value, we have to post it and substitute in the test statistics, that is x bar minus y bar by root over s into root over n1 plus n2. It is very simple if you follow these videos, and in my upcoming videos I am going to explain from example 7, and there ends the topic here. And if you go through one after the other videos from the playlist, clearly the textbook will be in your hands and your preparation will be damn easy, and you can prepare anywhere, anytime. And avail this opportunity. If you really like, please raise your thumb, pass it on to your friends, and that is the greatest help needed to this channel. Thank you for staying.